Slope. Slope is one of the most important characteristics when it comes to graphing lines. Slope is basically a measure of the steepness of the line. How steep is the line, or how fast is the rate of change? Slope can be large or small, positive or negative, and that tells us a lot about how the line is behaving. For example, positive slopes will go up from left to right, while negative slopes are going downhill from left to right. The larger the slope, the steeper the line, and the smaller the slope, the shallower the line. So the most obvious application of this is when you're skiing and you want to know how steep your slope is going to be. Well, your positive slopes are actually uphill, not very good for skiing, and your negative slopes are downhill. But you don't want to go too big negative because you're going down way too fast. So poor Tyler here should have paid more attention in algebra class, and he could have had a better skiing experience. But let's talk about how we can actually find measurements for slope. From the graph is probably the easiest way to see the slope. It's often considered the rise over the run, how fast we move vertically compared to how fast we move horizontally. So here are three different graphs with three different slopes. And we're going to try and measure how far they rise and run from one to another. I can pick any point on this first graph and any other point on the first graph here. And what you'll see is how far up and over we go from one point to the next will give us the slope. Notice this goes up 2 and over 3. We do rise over run. The slope rises 2 for every 3 it runs. And so we would say this line has a slope of 2/3. And you'll notice it does that all the way up 2 over 3. We have another point. We can even go backwards. Down 2, backwards 3. Another point. That slope keeps the same constant rate of change all the way up the line. Let's try another one. Here there's a point in the top left corner. This one's downhill, first off, before I get too far. Downhill, so we can assume the slope's probably going to be negative. It's pretty steep, so we're going to assume it's probably larger than just a fraction. But let's see what happens. We've got that first point on there. Maybe all the way down here we see another point down here. Notice to make our little slope triangle, we're going to go down several points, so that's going to be negative. We're going to rise a negative 1, 2, 3, 4, 5, 6. Rise a negative 6, and we only run over 2. So we rise negative 6 and we run 2. We can reduce that to negative 3. So the slope here is negative 3. Downhill, negative, like we expected. And so negative 3 is a fraction is 3 over 1. I can go down 3 over 1, and there's a point. Down 3 over 1, there's a point. Down 3 over 1, there's a point. That slope of negative 3 is going to remain constant all the way through, regardless of the points I pick. One last one. Let's pick a point right here and a point all the way down here. What's that slope going to be? We know it's going to be negative because it goes downhill. Goes down a ways and over quite a ways. Down negative 4, and it runs, what is that, 8? 1, 2, 3, 4, 5, 6, 7, 8. Yep. So the slope is the rise of negative 4 and the run of 8, which reduces to negative 1/2. That tells us this graph goes down 1 for every 2 over. Down 1 over 2, there's a point. Down 1 over 2, there's a point. Down 1 over 2, there's a point. It works backwards. Up 1, backwards 2, there's a point. All the points are separated by 1. Down 1 over 2. Slope measures the steepness. Now, we don't always have a graph to help us know how far we rise and run, so sometimes we have to calculate the slope from the points on the graph that we're told. And we can calculate this by finding the change in the y's and the change in the x's. So if we want to find the slope between these 2 points, x1, y1, that just means the x1, y1 just means it's the first point, the x and the y from the first point. And x2, y2, that's just from the second point, the x from the second point and the y from the second point. All we have to do is subtract the y's, and that tells us the rise. And if we subtract the x's, that will tell us the run. We have to subtract them in the same order. It doesn't matter which order we subtract, as long as whatever point we use first for the x's has to also be used first for the y's. So a few examples here. If we want the slope between 2, -1 and -3, 4, we'll call 2, -1 the first point and -3, 4 the second point. First, we subtract the y's. -1 minus 4. That's the rise over the run where we subtract the x's. 2 minus -3. Well, 1 minus 4 is -5. And 2 minus -3, if I add the opposite, that's 5. And so this actually reduces to a slope of -1. It's negative, so I know this line's going downhill. It's -1, so it's kind of a medium slope. Lots of good information off of that slope. How about the second one, -7,3 and -2,5? We're going to call -7,3 the first point and -2,5 the second point. Remember, they are x-y pairs. So we subtract the y's, -3 minus 5, over, we subtract the x's, -7 minus -2. Well, -3 minus 5 is -8. And if we add the opposite, -7 plus 2 is -5. Well, 2 negatives make a positive, so this slope is 8/5. This line's going uphill because we have a positive slope. This equation is one of the most important equations of algebra. It's a good one to commit to memory. Rise over run, subtract the y's, over subtract the x's, tells us our slope. M always represents the slope. Very important equation. We should now be able to find the slope on several examples on your homework assignment, whether I give you the graph and you look at the slope triangle, rise over run, or if I give you the points, you should be able to figure out the slope from those 2 points. So take a look at it, let your instructor know if you have any questions, and good luck to you on your assignment.